So after we understand how to define a procedure, the next thing is we need to see how we will invoke the procedure. Or, of course, we say that's a call keyword. Did you remember on Tuesday, we asked you to, using the Irvine 32 procedure, write string or read string. So you need to call write string and call read string. So that's why I write. So after you have a procedure defined, you will call a procedure. So the call instruction will call a procedure. And what this call will happen. So that's further to talk about that. You know you can call procedure. In C++, you just write the function and they will invoke the function. In assembly language, when you call a procedure, the first thing they will push offset of the next instruction into the stack. Then they will copy the address of the code procedure into the EIP. So the EIP is instruction pointer. So that's why from this instruction pointer, we will start executing that procedure. So then what means the offset of the next instruction? So then we will talk about that. So after you call procedure, you will run procedure from the first statement to the last statement, right? And did you remember earlier we showed you? When you call the procedure, you will, of course, you will start execute instruction line by line. So before you finish procedure, you will see the return keyword. So what this return instruction will do? Return instruction actually will return from the procedure. So that's why they will pop the top of the stack into the EIP. Okay, what does that mean? So here, remember earlier we told you, when you have your call procedure, you call a procedure, right? So the first thing, they will push the offset for the next instruction into the stack. So here, the next instruction of the stack being pushed, right? Pushing to the stack. So then we execute from the EIP. Then you return from the procedure, right? So then they will pop. Let me put the keyword, push, and the pop. So the pop, the top of stack into the EIP is what? Is what earlier you just pushed the offset of the next instruction into the stack. So what does that mean? Because every time when you return from the procedure, they should return back to where? They should return back to where you call the procedure, next instruction of the call procedure. So that's why here, when they pop that location for the next instruction from you call the procedure, they will copy over to instruction pointer. So instruction pointer can work from there. Let me see here if it will be more clear. We just see for example. So this example, you just pay attention. Of course, we have the machine code here. But one thing I just want you to pay attention, it just have a main procedure. In this main procedure, we call my sub. My sub is what? Is a sub, is a procedure. Okay? So you all understand now. If you have my sub defined, right? So don't forget I have return. So here you all understand if you call this my sub procedure, right? You are expecting you will come here, start from the first instruction, you're working on that one by one. Then after you're done, you return, right? You return back to where? You don't return back to here. You return back to the next line, next instruction after the call procedure. That's similar like C++, right? But now I want you to pay even more attention how those things happen. When we say we call procedure, of course, we come to this line. You come to this location. This location will be the first instruction in the procedure. But how do I know they come here? Right, did we say? When you call the procedure, right, they will copy the first instruction from the procedure into the EIP. So that's why instruction pointer can start working from here. But before that, you see here we say call. You call instruction do two things. The first thing, they push the offset for the next instruction into the stack. The second thing, they copy the address of the call procedure into the EIP. So here, this one, copy the address of the code procedure into the EIP is here. It's this line. Because when you call my sub, you will have your location, the first instruction location. They will copy this one, the 00040 to the instruction pointer. So they have this one in the instruction pointer, right? So that's why instruction pointer, no, they start working on from here, then go to the next. But one thing is we didn't finish this part, right? You copy over this one, we all understand. But before that, actually you need to do the first thing. You need to push the offset for the next instruction to the stack. So which one is the next instruction after the code? Yeah, this one, right? Because after your code, this one is your next instruction. So this next instruction, 25, will be pushed into the stack. So we see what happened. Actually, let's show you the picture like this will be easier. Okay, we all know, for example, my sub, actually the first line will start from 00040, right? So then here, when we call my sub, we do two things. The first thing, they find the next instruction location, or we say offset. They push this value into your stack, right? So you see, when we push into the stack, we find the ESP location, we decrement the ESP, we find the ESP location, we decrement ESP by 4. So then we add this value. Of course, here the question mark just means before what we have in the stack. So now when we call my sub, what happened is they just copy the next offset for the next instruction to the stack. So that's why ESP will point to this location. ESP stands for the stack pointer, right? So that's the first one you call. After you call, the first thing you do this one. Yeah, so here you push. So the first one you push the next instruction into the stack. Then the second thing you do what? Yeah, remember we said that, right? So the first thing you push into the stack. Okay, so then the second thing you see, remember, after you call the first, you push the next location to the stack. Then the second thing, you copy the beginning of the procedure, the first line in the procedure, copy to instruction pointer. So that's why instruction pointer have 40. So then after your instruction pointer at 40, right? So right, I just execute line by line. I execute line by line until I hit the return. When I hit the return, what we do? Right, we hit the return. You see, remember, return instruction, return from the procedure. You pop the top of the stack into the instruction pointer. So that's why here, after you done hit instruction pointer, hit the return, right? So then they will, when they hit the return, they will pop the next instruction into the EIP instruction pointer. So that's why afterward they look like this. So after your EIP go to the 25, mean what? Right, that's me. You come back to this location. Okay, so now have you better understanding about how the stack happen? So that's earlier I told you when we talk about stack in Tuesday, we say stack memory, right? So that means when you have like C++, when you call a function, how did you know you return back to the next line? Because whenever you invoke a function or a call procedure, the first thing they will push the next location where they return back into the stack. So then they know the first line, first instruction from the procedure or function. They copy into the instruction pointer. Instruction pointer always point to the next instruction they want to execute. So once they execute line by line, when they see the return, so the return will automatically to pop the value from the stack into the instruction pointer. So that's why instruction pointer can go back to the main function, the next line after you call the procedure. So that's how the call instruction and the return instruction, what they happen, what they affect our stack, and how they affect our instruction pointer. So this one is not only happen in the assembly language procedure. you will think about it happen for the C++ function as well. Of course, this example will only show you when you found the main function, you call one procedure. But remember, a lot of time, you have the nested procedure codes. Or in C++, you have many functions called one by one. A nested procedure call actually happens when you call procedure. So this code procedure actually call another procedure before the first procedure even finish. For example, in your main function, in the main, you call a procedure. This procedure, just say that's the sub1. Before the sub1 finish, actually sub1 call another procedure is sub2. So then the sub2, before they finish, they also call sub3. So what will happen? What will happen is, right, after the sub3, if sub3 don't call any other procedure, after sub3 finish, they will return back to sub2. So then sub2 continue to execute, then they will return back to where the next line in the sub1, they call the sub2. They go back to the sub1. So then after sub1, do line by line, sub1 return, right? But when they return to the main procedure, they don't return to where they call. They return to the next line, the calling procedure statement. So that's why in the stack memory, you will see what happened. You see here, we just say, for example, that's our main procedure. You call sub1 here. So later they will come back here. Okay, so that's why you call sub1, but the next line from the call sub1, the offset 1 will be pushed to the stack. So then, of course, instruction pointer point you to the first line from the sub1 procedure. So then sub1 procedure instruction pointer do line by line, right? Then they decide to call the sub2, right? So call procedure, right? Call procedure will always call instruction, always copy the next line, the offset for the next instruction, and push to the stack. So then you will see here afterward your offset, we just say here is offset 2, push to the stack. So continue since you call, right? So after you push to the stack, so the beginning of sub2 will be copied over to the instruction pointer. So they do line by line. So then they call sub3 again. So before they go to the sub3, they will have the next instruction offset push into the stack. So then we call sub3 procedure. The first line of the instruction will copy over to the instruction pointer. So then they execute one by one. So then when they return, they will automatically pop the first one, pop the top value from the stack. So of course, offset will copy over to the instruction pointer. So then bring instruction pointer to here, the offset 3. You see the line after the statement after you call sub3. So again, this one is the return, good. So return, I just pop the top value into the instruction pointer. So bring us to here. So that's return, good. So I pop the top value from the stack to the instruction pointer. So I come to the offset 1. So then we finish one by one. So that's why did you see when you do the nested procedure code, actually that's how your stack memory do one by one. And also that's earlier we told you, right? When you have the sequence function code, the last function you code, they will finish first. So that's why the memory will using the stack, because the rest of that will be pop. So then the rest of that will be pop until you come back to the main procedure. Yeah, so also you can see this one actually is we pop one by one. Okay, so that's why at the end, after you finish that, you see your ESP will point to the location before the offset 1. So then they all came back to the beginning. So at the end of this video, I also want to talk about the local and the global label. Before, if you have a code label, it's only one column, that's the local label. If you want to make the global label, you need to do the double column. So in one procedure, they only can jump to their local label. they cannot jump to other local labels.